Welcome to RankLens. Today, we count down the top 9 most massive black holes ever discovered. Black holes are the universe's heaviest hitters, cosmic guillotines where gravity wins. But some black holes aren't just massive, they're absurdly massive. We're talking objects so colossal they warp the fabric of space-time around them. Today, we're counting down the 9 most massive black holes ever discovered, the cosmic titans that shouldn't exist yet do. From a 55 million light-year neighbor to a 10 billion light-year monster, these are the black holes that rewrote what we thought was possible. Strap in. We're going deep. At number 9, we have NGC 4649, also known as Messier 60 or M60 for short. This black hole weighs in at 4.7 billion solar masses. That's almost 5,000 times the mass of Sagittarius, ACE-Y, the black hole at the center of our own galaxy. M60 is one of the largest elliptical galaxies in the Virgo cluster, a dense traffic jam of galaxies, a stone's throw from us in cosmic terms. What makes M60 especially fascinating is that it isn't sitting alone. It has a close companion galaxy, NGC 4647, and the two are gravitationally locked in an intricate dance. Their mutual gravity tugs and pulls, slowly pulling them toward eventual merger. And here's the kicker. At just 55 million light-years away, M60 is the nearest black hole on this entire countdown. It's close enough that we can study it in detail, yet far enough to feel impossibly remote. At number 8, we have M87 NICE, the Event Horizon Telescope's headliner. This black hole packs 6.5 billion solar masses. But here's what makes it unforgettable. In 2019, we actually saw it. The Event Horizon Telescope, a globe-spanning network of radio observatories, captured the shadow of M87's event horizon, a breakthrough moment in astrophysics that made headlines worldwide. But M87's violence doesn't end at the event horizon. This monster launches a relativistic plasma jet, a stream of superheated matter traveling at nearly the speed of light that shoots thousands of light-years into the surrounding space. These jets are cosmic spotlights, broadcasting the black hole's power across intergalactic distances. At 53 million light-years away, M87 Animus is not only one of the closest imaged black holes, it's the closest we've ever caught, red-handed, its shadow burned into our records forever. At number 7 sits NGC 3842, the dominant black hole in the Leo cluster. At 9.7 billion solar masses, this black hole is nearly twice as heavy as M87, and it's a cosmic rule-breaker. In 2011, when astronomers precisely measured NGC 3842's mass, the result shocked the field. It far exceeded theoretical predictions for its host galaxy. NGC 3842 didn't care about theory. As the brightest galaxy in the Leo cluster, itself part of the dense collection known as Abell 3067, this black hole dominates its environment. Its gravitational influence extends thousands of light-years from the galactic center. Sitting roughly 320 million light-years away in the constellation Leo, NGC 3842 represents a threshold moment, the realization that we had underestimated how monstrous these cosmic beasts could grow. At number 6, we jump billions of years backward in time to meet SDSS J0100 plus 2802. This quasar hosts a black hole of 12 billion solar masses, but the when is more staggering than the how heavy. This black hole existed when the universe was less than 1 billion years old, a cosmic newborn hosting a monster it had no business creating. SDSS J0100 plus 2822 is one of the most luminous high redshift quasars ever discovered, blazing so bright it outshines entire galaxies of normal stars. The problem? Its existence shouldn't be possible. Our best theories say black holes of this mass need far longer to assemble. They need time to grow through collisions, mergers, and patient accretion. Yet here it is, fully formed and raging at cosmic dawn. SDSS JO 1/3 28 do force theorists to rethink growth timescales and ask, how much faster can supermassive black holes actually grow? At number 5, we have NGC 1600, a loner among giants. This black hole weighs 17 billion solar masses, a true heavyweight. But NGC 1600's real story is about where it lives. Most black holes this massive are found in rich, dense galaxy clusters, cosmic cities packed with thousands of galaxies tightly squeezed together. Not NGC 1600. This elliptical galaxy sits in a surprisingly sparse galaxy group, a cosmic suburb with far fewer neighbors than theory expected. That's a puzzle. We thought you needed a crowded environment to build such a monster. Collisions, mergers, gravitational encounters feeding the black hole endlessly. Yet NGC 1600 thrived in relative isolation. Its discovery fundamentally challenged our understanding of where monster black holes can grow. It showed that the densest regions of the universe aren't the only nurseries for cosmic titans. Sometimes, a black hole just needs patience and accretion, regardless of its neighborhood. At number 4, we meet OJ 287, and this black hole has a partner. The primary black hole weighs 1835 billion solar masses. A smaller black hole orbits it in a deadly dance, producing brilliant outbursts roughly every 12 years. OJ 287 is a blazar, launching jets directly at us, so these flares punch through with extraordinary brightness. What makes OJ 287 extraordinary is that this binary black hole system offers astrophysicists a cosmic laboratory for testing general relativity. Einstein's theory predicts the orbit should decay. The flares follow a precise schedule, and the dynamics unfold in a very specific way. Observations match theory with remarkable precision, confirming Einstein's century-old predictions on a cosmic scale. At number 3, we have NGC 4889, the undisputed ruler of a cosmic metropolis. This black hole packs 21 billion solar masses. NGC 4889 is the brightest elliptical galaxy in the Coma cluster, one of the densest galaxy concentrations ever observed. The Coma cluster is a city of thousands of galaxies packed into a relatively small region of space, and NGC 4889 dominates it completely. The black hole's gravitational influence reaches thousands of light years from the galactic center. This monster sits at the crossroads of constant galactic collisions and mergers. Every encounter feeds the black hole, swelling its mass further. NGC 4889 represents the final form of a black hole, shaped by chaos, merger after merger, in one of the universe's busiest neighborhoods. At number 2, we have Holm 15 Ace, a black hole hidden inside a paradoxical galaxy. At 40 billion solar masses, it's twice as heavy as NGC 4889. Holm 15 Ace resides in the Abell 85 galaxy cluster, roughly 700 million light-years away. But its host galaxy has one of the most diffuse, low-density cores ever observed. Imagine a black hole of staggering mass, surrounded by an almost empty galactic center, a cosmic paradox. How did this happen? Astronomers believe Holm 15 grew through successive major galaxy mergers. Each merger brought fuel and swelled the black hole, while scattering stars outward and hollowing the core. The result is extraordinary. One of the heaviest black holes ever discovered, cradled within one of the faintest galactic centers known. At number 1, we reach the summit, 21618, the most massive black hole ever discovered. This black hole weighs 66 billion solar masses. To put that in perspective, you could fit 66,000 objects the mass of our Sun into its gravity well. TUN 618 is a hyperluminous quasar located about 10 billion light-years away, a relic of the universe's wild youth. The most mind-bending fact, its event horizon has a diameter exceeding the width of our entire solar system. From the Sun to Neptune is about 6 billion kilometers. TON 618's event horizon is bigger. It's one of the most luminous objects ever detected in the universe, blazing so bright it outshines billions of galaxies. TON 618 is the limit, the champion, the monster that rewrote what we thought possible. These 9 black holes span a staggering range, from 4.7 billion to 66 billion solar masses. They reveal something deeper than just numbers. They show us that the universe's most extreme objects defy our intuition and challenge our theories. Some grew impossibly fast. Others thrive in unexpected places. Many warp space-time so dramatically, they become laboratories for physics itself. These black holes didn't exist in our predictions. They forced us to expand our understanding of gravity, growth, and what the cosmos can build. As telescopes grow more powerful, we'll find more of these monsters. The universe still has surprises waiting, and that's the top 9 most massive black holes ever discovered. If you enjoyed this countdown, subscribe to RankLens for more.